Let's do this problem from your lab assignment. This is section 6.5, problem number 1. In a certain city, the temperature in degrees Fahrenheit T hours after 9 a.m. Was modeled by the function T of T, that's capital T for temperature, little t for time, is equal to 49 plus 16 sine pi t over 12. Find the average temperature during the period from 9 a.m. to 9 p.m. Okay, so this has some shift to it. We're going in hours, but you have to translate this into t. So if 9 a.m. corresponds to t is equal to 0, then 9 p.m. would correspond to t is equal to, well, there's 9, 10, 11, 12, plus another 9, so that's going to be 3 plus 9 is 12. Okay, now we use the formula for the average value of a function. That's 1 over b minus a, and then we integrate from a to b of the function. So we found the number 12, so that's b, and then a is equal to 0. So it's 1 over 12 minus 0. We integrate from 0 to 12 of this function. Now this function has two terms in it. Has a 49 and a function 16 times sine pi t over 12. So we're going to split that up, and first we're going to integrate 49 dt, and then we'll integrate the sine function. We'll move the coefficient outside. So we integrate 49, the constant 49, so that's going to be 49t, and then we're going to put 12 in. We put 0, it's going to be 0, so it's going to be 49 times 12 in our graphing calculator, or our regular calculator. 49 times 12 is 588, and so that should be the first integral. Now we're going to integrate the second using a u substitution, because the argument inside of the sine function is more complicated than just a regular variable. So we're going to let u equal to pi t over 12, the derivative of that. Well, pi over 12 is just a constant, and so we take the derivative of constant times t. It's just going to be the constant. And when we do the u substitution, we're also going to change limits. So when t is equal to 0, we're going to put 0 in for t and figure out what your u limits are. So when t is equal to 0, u is going to be 0. Now when t is equal to 12, this is going to be pi times 12 over 12. The 12s would cancel, and all we have left is pi. Now that we have that, we do our u substitution. Our integral becomes du. Notice the limits have changed to 0 to pi instead of 0 to 12. And then the u substitution had a pi over 12 dt, and so if you're going to replace dt, you need a 12 over pi as a constant that you can take out. And now that we have that taken out, 16 times 12, I guess it's 192. The antiderivative of sine u is negative cosine of u from pi to 0. So cosine of pi, I think it's going to be, so this is the negative that comes from this negative, and the cosine of pi is negative 1. And then minus, and then we have to figure out the negative from here, and then the cosine of 0 is positive 1. So this is what we have, basically a negative, negative, so it's a positive one, negative, negative, that's another positive one. So this is just 1 plus 1. And so it's 192 times 2 essentially. We could do that in our heads, or since we have our calculator open, we can just say it's 384 for the numerator, and then our denominator stays the same. So going back to what we have, the average temperature is going to be 1/12. So that's the 1/12 from the fraction in the front, and then we're going to find the integral. So the integral for the first part I think was 588, and then we're adding, and the second part was 384 divided by pi. And so if we're going to punch all this stuff in our calculator, let's get our calculator out again. We have a 384 and divided by pi. There's pi. We're going to add 580, say equals. Well, we'll just add 588 to it. And then after that, we're going to divide it by 12. And then to the nearest degree, so this looks like it's going to be 59 degrees. Which is approximately 59 degrees. All right, let's go ahead and check that. Yeah, it didn't look like it was 59. Oh, maybe they wanted an expression, so I'm just going to type this in and see what they come up with. 588. I suppose you can find common denominators here, but I'm just going to skip that part. 384 divided by pi and close parentheses. So that's the exact value. So if you multiply this through, this simplifies to 49 plus 32 over pi. Okay. Before we sign off here, let's take a look at the graph of this, because I think there's some interesting things to look at. Let me see if I can pull the graph out. Here's the graph. Let me see to make sure that this is the right function. The original function was 49, so this is 49, and then plus 16 times sine pi times t over 12, and then this has a restriction of going from 0 to 12. Okay, so let's see if we got that correct. Oops, that's not 16, that's 100, and that's too much. There we go, 16. All right, so this is the graph, the small bit of the graph that we're looking at. Let's see if we can zoom in a little bit. So what we're saying here is that if we graph y is equal to 59, which is what our graph was, it looks like this is going to be the average value. Okay, so what this is saying is that if we were to graph this shaded in, 0 less than y less than 59, from 0 to 9 to 12, what they're saying here is that the area in this rectangle is the same as the area that's going to be, well, let's see if we can copy this. Except let's do a less than here. So I have two shaded regions, That's a little too big here. Let's zoom out. There we go. So I have two shaded regions, and what they're saying is that this is the area under the curve for the graph that we're looking at, and this is the average value function at 59-ish. And then what they're saying is that the area in this rectangle is the same as the area under this curve. So that's one way to interpret the average value. The other way to interpret the average value is to say that this line y is equal to 59 is going to be the average value for all these points in this continuous graph with a sign. Okay, so that's the idea behind the graph of the average value function. Okay, I hope that helps.